Hi everyone and welcome to the discussion of Book 1, Proposition 9 of Euclid's Elements. Proposition 9, to bisect a given rectilinear angle. This is a construct proposition. It shows how to bisect an angle in general sense. So what is a rectilinear angle? Definition 9 states, and when the lines containing the angle are straight, the angle is rectilinear. Recti means right or straight to consider our context. Hence, the rectilinear angle is an angle produced or contained between two straight lines, or we can say an angle between straight lines. This proposition 9 is being cited when we need to divide angles in our proofs for the other propositions. And to give everyone an overview on what to expect for the construct and the proof part, here are the components. The first one, constructing an equilateral triangle through having circles. So that is based from proposition 1 and definition 20. And we also have the cutting off and connecting of points into a line. So that's proposition 3 and postulate 1. And we are also using the parameters of a circle. That's definition 20 and the parameters of congruent triangles at proposition 8. So let's proceed. So let's now construct a figure. So everyone, this is our to be state for the construct or our endpoint for these steps. Okay, so we will just follow the step-by-step procedure of the construct here. Okay, and while I'm doing it at my end, you can also perform the steps at your end. Okay, so let's do this together. So the first one is to construct a rectilinear angle BAC. So let's do it together. So side AB and side AC. Okay, so we now have an angle BAC. And the second step is to draw a circle with A as the center. Okay, and we will consider our target for this step is to have points D along line AB and point E along the line segment AC. Okay, so let's do that. Okay, circle and point D here. Okay, and the intersection of circle A and line segment AB is point D, and the intersection of line segment AC and circle A is point E. And considering the definition of circles, we can say that radius AD is equal to radius AE. Okay, so keep that in mind. Then the next step is to construct an equilateral triangle. So to do that, we will draw a circle with center D and radius DE. So let's perform that. Circle D, radius DE, and a circle E with radius ED. Okay? And the point of intersection between circles D and E will be a point named F. Okay. All right, so let's now construct the equilateral triangle. Okay. Side EF, side EF, and side DE. And we will then join points, We will then join points A and F to have the line segment AF. Alrighty. Okay, so there you have it. That's the figure of proposition 9. So let's proceed to the proof. If we will look closely to the figure, we can say that we have triangles DAF and triangle FAE, right? Okay, and it's kind of obvious that those two triangles are equal. So this will give us a hint that we will going to use the parameters of congruent triangles. So we can recall proposition 8, the side theorem. All right, so let's now define the three pairs or the three corresponding sides. Okay. The first side would be the radius or the radii of circle A. So we have side AD equal to side AE. So keep that in mind. So that's our first pair of sides. And the next pair would be sides DF and side EF. And why are they equal? Because these are sides of the equilateral triangle produced by circles D and F. Okay, so side DF is equal to side EF. And for the last pair, the base, okay, the line AF. And yes, AF is equal to itself, AF. There you have it. We now have the three pairs of congruent or equal sides. AD equal to AF, DF equal to EF, and AF equal to itself. Hence, we have triangle DAF congruent to triangle FAE. And using the parameters again of congruent triangles, we can say that the angles contained inside the congruent triangles are also equal. So therefore, class, we can say that angle DAF is equal to angle FAE. And again, these two sub-angles were produced after we have the line AF that bisects the big angle BAC. Again, with angle or with line AF, we have produced two equal sub-angles DAF and sub-angle FAE. So again, by producing points DE through a circle A and then producing an equilateral triangle by drawing circles D and E, okay, and by having or by connecting A to F, then we have produced two congruent triangles. And using the parameters of the two congruent triangles, we just have shown that subangle DAF is equal to subangle FAE. So thank you everyone for watching this video, and I'll see you all to another discussion of another proposition. So thanks again and take care.